In this demo, I'll demonstrate how to compute the curve number using both the SSURGO soil type dataset and the National Land Cover database using WMS. And so the first thing I'm going to do is use the hydrologic modeling wizard to identify the project bounds that I'm going to be working in. It brings up the locator tool, and I'm going to zoom in on a location that I'm interested in, Huntington, West Virginia. It's a blend of urban and rural. That's going to be in the study area here. The data that I'm going to download, I'm going to use web service to get the downloads, and the data I'm interested in is the 30-meter elevation data and the National Land Cover database 2006, also at 30 meters. I'd love it if I could get the soil type, but that always crashes for me. It never gets the soil type. It doesn't crash, but it never gets the soils. I have to load that externally. So it will get the DEM and the land cover. So I'll click download, and it goes and gets that data. Have to specify the cell size. Sometimes it'll give you an option other than the resolution that you're downloading originally. It'll downsample it so that the download takes a little bit less time. We don't have to do that. So you can see here's the classic DEM, and if we take a look at what the land use looks like, similar kind of shadings to indicate the urban areas versus the rural areas. This is a TIFF file. The land cover data is a TIFF file, georeference TIFF, that the colors represent different land uses. Okay, so if I go back to the modeling wizard, my next step will be to calculate topaz, and that is where it is computing what flow directions there are in the DEM. And if we close this and take a look at the DEM again, now it's defined streams. Those little blue lines are indicating where streams are likely to form. And so if I wanted to take a look and add a map in the background there so that I can see what streets are in this area, it will over here be streaming the map, and I automatically get a higher resolution version of the map depending on where I zoom in. It's again processing, and let's say for example that I was interested in locating a culvert where this stream crosses a road. So if I put my outlet there and then tell it to compute what is the watershed, delineate the watershed, I can click on that, and it's automatically calculated the watershed contributing area. You can see 11.48 square miles, but it doesn't yet know the curve number that it would need for subsequent hydrologic modeling. And so land use is part of the equation for having it find the curve number. The other thing we need to add is the soil data. So I'm going to right click on the GIS data and add shapefile. I'm going to be adding some soil data that I downloaded previously, and it's a shapefile that was in a folder of other shapefiles, but it's obviously where the data is. It's the very large shapefile, and if I load that in, you can see a bunch of polygons are there, and I'm going to go back to my previous zoom extents, and those polygons will overlap the entire project area that I'm interested in. And what I'm going to do is I'm going to select the polygons, select certain shapes. Oh, first thing actually, I'm going to right click and join NRCS data. What that does is it joins the hydrologic group going to a data table that is separate from those shape files, and it's going to associate what the hydrologic soil group, A, B, C versus D, with each of those polygons. And so it's associating that. Another thing I'm going to do is create a new coverage. I'm going to create a soil type coverage, and this isn't strictly necessary as a step. You can compute the curve number without the separate coverage unless you've got a very large area. Then having this coverage sometimes will help you to have success when otherwise the program might run very slowly or crash if a lot of extraneous areas are included. And so I'm going to switch this off and make sure I've got my entire project area. Oops. Zoom out on my entire project area. Okay, so I want to make sure that I select the polygons that's inside my project area. So I've got them all there, and then I can go to shapes, map the shapes to the soil type coverage. So it's getting them from the shape file, it's going to put them in the soil type coverage, and want to make sure that it sees the hydrologic soil group. In this case it looks like there were some blanks, which surprises me. So I'm going to cancel that, right click, join NRCS data, fill blank values. So anything it sees as a blank it will assume is a C, and it chooses that based on what was the most common thing inside. And so again, if I go back to the no blanks now, and finish. Alright, so if we delete this, we can see that all the soil polygons are now in the soil type coverage, and with that I can calculate the curve number. If I go into the hydrologic modeling module and use this calculator, compute GIS attributes, then import a table that is sort of the key for what land use and soil type combinations are associated with a certain curve number. It's going to use the soil type coverage for determining soil type. It's going to use the grid for determining the land use. And if I click OK, then it'll automatically perform the calculations. It'll pop open a little summary table that shows what the curve numbers calculate out to be. And if you go back into here, you can see it's automatically filled in that calculated curve number in the attributes for the watershed, so that if I was going to create a HEC1 model, I can double click on here and it'll bring up the attributes. Then we already have that the curve number of 72 is filled in the loss methods. So in summary, that demonstrates how you can calculate the curve number using SSURGO, soil type data, and National Land Cover Database for characterizing the land use automatically using WMS.